This video is for Chapter 5, Section 1, and it's all about triangle midsegments. First thing we're going to do as we look at triangle midsegments is we're going to put together a little bit of coordinate work and explore the midpoints of sides of triangles in order to create these midsegments. So here we have a triangle X, Y, Z, and what I've done is I've placed 2 points A and B, and we're going to use these points as the midpoints of those sides. So A is the midpoint of XZ and B is the midpoint of YZ. First thing we can do is use the algebraic midpoint formula to find the coordinates of point A. So for example, point X goes from 6 to Z at 12. X is at up 10 and Z is at up 6. So to find the middle, we can use the formula of 6 plus 12 divided by 2, which is 18 divided by 2, which is 9. Halfway between 6 and 12 is 9. Makes sense. 10 plus 6 is 16, divided by 2 is 8. Well, halfway between 10 and 6 is 8. So this is the point 9, 8. On a number line between 6 and 12, we're at 9. And on the number line between 6 and 10, we're at 8. 9, 8. Now for point B, we're at 2 plus 12, which is 14, divided by 2 is 7. And 4 and 6, if we add those together, we get 10. Divide by 2, we're at 5. The midpoint B is at 7, 5. 7 is halfway between 2 and 12, and 5 is halfway between 4 and 6. So we have point A at 9, 8 and point B at 7, 5. Now we're going to look at a few things using these coordinates because these are guaranteed to be the coordinates for this mid-segment, connecting two midpoints. So the first thing we're going to look at is the distance between A and B, or the distance of this segment we have created. The distance, if we're writing this down, we should note that A and B are midpoints, and we should note that this is the distance or length of A to B. The formula says x2 minus x1, 7 minus 9 squared, plus y2 minus y1, 5 minus 8 quantity squared. Now both of these numbers become a negative, but when we square them, they become positive. This is the distance from 7 to 9 is 2, so it goes 2 to the right. And between 8 and 5, it's 3, so it goes 3 up. 2 squared is 4, 3 squared is 9. So we're at the square root of 4 plus 9, which is the square root of 13. This is approximately 3.6 for our length between A and B. Now, what I want to look at is the distance of A to B compared to the distance from X to Y. So I look at the distance of X to Y, and I have Y2, or X2 minus X1, 2 minus 6 equals, or squared, is 4 squared, and then 4 minus 10, which is negative 6 squared. Again, the negatives will cancel out. Negative 4 squared is 16. 6 squared is 36, which is equal to square root of 52. Now, when we take the square root of 52, it is 7.2. What I notice is that this is exactly double what AB was. XY is exactly double the length, or we could say that AB is half the length. So when I connected the two midpoints, the segment was half as long as this side of the triangle. The other thing we can find with coordinates is slope. We can find the slope of xy, which is this line here, as being y2 minus y1, 4 minus 10 is negative 6, over x2 minus x1. This is all algebra work. Negative 6 divided by negative 4 is 3 over 2. So it has a slope of 3 over 2. It rises 3 every time it goes to the right 2. Up 3, right 2. Up 3, right 2. Now when we take a look at AB, y2 minus y1, so 5 minus 8 over 7 minus 9, that becomes negative 3 over negative 2. which is 3 over 2. They have the same slope. Now, if we think back to algebra, what we learned about two lines that have the same slope, well, that would mean they go in the same direction. Each line is going up 3, right 2. The other one's going up 3, right 2. Well, when two lines go in the exact same direction, they are parallel. We can make the conclusion from this information that XY and AB are parallel. This is using algebra to prove the things that we want to know about a triangle's midsegment. So let's move forward. Triangle midsegments. First of all, let's go to a definition. A triangle midsegment is a segment that connects the midpoints of two sides. D is a midpoint, E is a midpoint. Connect D to E and you have DE as a midsegment. DE is a mid-segment. D is a midpoint, E is a midpoint. So if we connect two midpoints, we have created a mid-segment. That's its definition. We have not said anything about its length or anything like that. Just the definition is connect two midpoints. Now you can call it a mid-segment. But what we learned on the previous screen is that when we connected two midpoints, it became half of the distance and was parallel to that third side. This is the triangle midsegment theorem. We have now already proven it using algebra. If a segment joins the midpoints of two sides of a triangle, in other words, if it is a midsegment, so if it meets the definition of a midsegment, then the midsegment is parallel to the third side and half its length. Look in this picture here to see the conclusion. P is a midpoint, Q is a midpoint, so PQ is a midsegment. And now we know PQ is 1/2 of ST and PQ is parallel to ST. So my conclusions are PQ is parallel to ST, and because X, the distance, is half of ST, PQ's length, or X, is equal to 10. This is the triangle midsegment theorem. Here are a few examples of how we might use this material. You can take a moment right now to freeze the video or press pause and try to answer these questions before you see how they work and see if you come up with the correct answer. Now that you've done that, I'll go through these problems and you can check your work. So on the first problem, I see congruent, 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 congruent. I see a midpoint and another midpoint, which means this is a midsegment. And a midsegment is always equal to half the third side. So I have two different equations I could use here. 2x plus 6 is equal to 1/2 of 56. Or I could multiply the midsegment by 2 and set it equal to 56. Now, I'm going to do that in a different problem. In this problem right now, I'm going to go with 2x plus 6 is equal to 28. That's half of 56. Now I can subtract 6, which brings me to 22, and divide by 2, and I end up with x equals 11. I have skipped a few steps here, but the algebra work is something you should be able to do. So, x equals 11 was our first problem. Now we have our next problem here. Midsegment, definitely a midsegment. So the midsegment is equal to 1/2 of the third side. We might want to go with 32 equals 1/2 of 4x. Now we can do this because we can take 1/2 of 4x and make it 2x. But an interesting one might be to say that 2 times the mid-segment equals the large side. So 2 32s equals 4x. That can be done. That makes sense. 2 of these equals 1 of the big ones. So that means 64 is equal to 4x. And now I divide by 4 on both sides, and I get 16 equals x. Problem number 2, done. The mid-segment is 1/2 of the third side. So the mid-segment is 1/2 of the opposite side, or 2 times the mid-segment equals the third side. Now this problem is not a triangle. It's a quadrilateral. There are a couple triangles inside. Here's one. And here to here is a mid-segment. And from here's another triangle. And here to here is a mid-segment. So if we actually just look at the triangle that I will try to highlight in blue here. If we just look at that triangle, this mid-segment right here must be 1/2 the third side. 30, half of 60. So the other triangle that I need to work with is the one here that I'll outline just on the outside of here. The midline in the middle is still there. Now this triangle has a mid-segment here that should be half of its third side, 25. And now we can see that we have 30 to here and 25 to here. So the grand total for AB is going to be 55. You may be making a conjecture that the mid-segment here is the average of the top and the bottom. And in the case of a quadrilateral with 2 midpoints with a diagonal connected through the midpoint, this is a true statement. These are your examples of how to work with triangle mid-segments. This was Chapter 5, Section 1.